Hello everyone, this is the part 2 of lecture number 10 in which we have already find various quantities of beam. Now we discuss our second part, how we find the other varieties like quantities of reinforcement. So in this beam we have find main bars and bent up bars and anchor bars. Now we have to find the weight of stirrup bars. In our yesterday lecture or previous lecture, we discussed this all things, how we find the straight bar, how we find the bent up bars. This is the formula, how we find for 0.45x. This is the stirrups. So now we move on our second measurement sheet, how we find the other quantities. In our previous lecture, we already discussed how we find the weight of reinforcement for 20 mm dia bars, which is the main bar, 20 mm bent up bars, 12 mm anchor bars. Now we discuss how we find the weight for a stirrup bars. So here we have given 10 mm stirrups. So we have to find the quantities of reinforcement for stirrups. We have to find number of stirrups also. How much stirrups we provide from this end to this end. So how we find that? First we have know that there is a formula for finding the straight length of bar is 2a plus b plus 24d. Here d is the diameter of bar. So here we have one stirrups. For example, this is our A, this is our A, this is B and B. So we have to find this length and this length. So how we find this length? Here we find first A. So A is equal to 0.75. 0.75 why? Because total height of this beam is 75 mm or 0.075 meter. Minus 2 into 0.05. Here 0.05 is the clear cover. Cover. So we have to deduct cover also. So from cover 50 mm from here and 50 mm from here. So we get this value 2 into 0.05 and we have to deduct reinforcement also. We have provide here stirrups because we have to calculate total length. So we here deduct 2 into 0.010 as a reinforcement. So we get here total length is the 0.63. Similarly, we have to find for a B. So B we know that here we have 0.40. For 0.40 as a bit, we have to deduct same cover 2 into 0.05 and we have to deduct same reinforcement from here. So we get here 0.28 as a answer. So simply we have to put this value in our formula. So 2 0.63 plus 0.28 plus 24 into D. D is the diameter of stirrups. So diameter of stirrups is 10 mm. So 0.010 meter. Here we get 2.06 as a length. So total stirrups length is 2.06. Now we have to find number of stirrups. So how we find number of stirrups? Number of stirrups is equal to 0.9 upon 0.12. So 0.9 is the length and 0.12 is the center to center spacing. Here 0.9. Why we provide 0.9? In our diagram we have given 0.9 meter as a length where we have to provide the stirrups of 10 mm dia. That's why here we take 0.9 as a value and 120 mm as a center to center spacing. So here we provide 0.12 meter plus 1. Why we provide here plus 1? We already discussed in our previous lecture. So total bars we get here 17. So simply here we multiply this value and we get 21.71 kg as a quantity of stirrups. So if you see in our diagram, we provide stirrups in various center to center spacing. So we have to cut this beam from center. So we have to calculate this value and this value. So this is the symmetry. So the value which we get here simply we have to multiply with 2. So we have find stirrups from that side to this side and we have to multiply with 2. We get the both side stirrups. So we have given First stirrup is 0.9 meter, second is 0.7 meter, and third one is the 4.8 meter. So in second stirrups we have provided 0.7 meter, means up to the 0.7 meter, and center to center spacing is 200 mm, and from middle part we have provided 4.8 meter. This is the 6 mm stirrups and 300 mm center to center spacing. So in our quantity we use this value. So for 10 mm stirrups we have provided here at a 0.7 length, and center to center spacing is 0.2. So here we calculate number of bars is 9. So simply we multiply this value and get here 11.49 as a answer. Same we have find a plus b value here. Same we have to find a plus b value here, and same we have to find here also. Only the thing is that the number of stirrups bars is changed from this end to this end, because we know that at the end, means at the support, we have to provide stirrups more, and we provide lesser stirrups in center, because we know that cracks is came at 45 degree at the support. That's why here we provide more stirrups. So we have to find similarly for a 6 mm dia stirrups. Here we provide these stirrups at a length of 4.8 meter, and center to center spacing is 0.3. If you see here, we multiply with 2 here, we multiply with 2 here. Why? Because we cut this beam from center. So this part and this part we get. So we find value for this part only. Simply we multiply by 2, we get this value also. But at center we have to find single bars. That's why here we not multiply with 2, and total bars here we get 17. So we get here 17, and 2 is the length, and total per meter weight of bar is 0.22. You also know that how we get this, with the help of formula T square upon 162. So simply you get 0.22 kg per meter weight of reinforcement, and you multiply these values and you get 7.48 kg as a weight of reinforcement. So you simply add this A, B, C, D, E, F, and you get total weight of reinforcement is 257.13 kg. So this is the quantity we find for a beam, reinforcement, formwork, and concrete. In our next lecture, we study about the bar bending schedule. Thank you.